Hey everybody, welcome back from spring break. My name is Mr. Pinta, and today we're going to be starting Unit 8, Day 1, Exponent Properties. So, what we're going to do is, I'm going to set a 2-minute timer. Would everyone please, actually not 2 minutes, maybe a minute. Write each of the following in expanded form. Number 1 is done for you as an example. So x to the 4th is x times x times x times x. Would you please do that for each of the following? 1 minute, go. All right, welcome back. So x to the 4th times x to the 5th. This would be x times x times x times x. That's x to the 4th. Times x times x times x times x times x. Now, notation is kind of inconsistent here, but that's okay. Multiplication, we can use a dot, or we can use nothing in between variables, and that means the same. We technically could put parentheses around everything, but that gets kind of cumbersome. The one that I would recommend not using is an x, because we have x's here. All right, next one, x to the 7th, 1, 2, 3, 4, 5, 6, 7, over x to the 3rd, 1, 2, 3. Next, we have x squared to the 3rd. So x squared is x times x, and then we have that to the 3rd, which means we're going to have 3 groups of those. Okay. The next one, we have x to the 4th, y to the 3rd, and then that's to the 2nd, which means we'll end up with one of them, and then another one. All right, so that's what you should have been able to do based on the example, but let's kind of go back and look at what happened. So we had x to the 4th and x to the 5th. How many x's did we end up with? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is x to the 9th. Do you see any way that we could go from x to the 4th times x to the 5th becoming x to the 9th without writing it all out? Well, hopefully you see that if we add the 4 and the 5, because here there are 4 x's and here there are 5 x's, we just have 9 x's. So we could actually come down here and put that in our summary. If we have x to some power, let's call it a, times x to some power, let's call it b, that means we're going to have a bunch of x's and a bunch of x's. How many x's are we going to have? Well, we're going to have a plus b. The same thing here. We did 4 plus 5. Same thing we do down here, a plus b. Okay. Next, we're going to have x to the 7th over x to the 3rd. And we had 7 x's over 3 x's. Now, same thing with numbers. We can end up reducing. And we end up with 4 x's remaining. So is there a way that we could have gone from x to the 7th to over x to the 3rd to x to the 4th without writing it in expanded form? Well, hopefully you see that if I subtract 7 minus 3, I end up with x to the 4th. So let's turn that into a summary. If I have x to the a over x to the b, well, that ends up being, x to the a minus b. Now, there's a lot of different expansions we can do to that. Let's actually do a little side work on an expansion. What if I had x to the 2nd over x to the 5th? If I wrote that in expanded, it'd be x to the 2nd, sorry, xx, and then x to the 5th. So if I reduce again, then I end up with 1 over x to the 3rd, because the 3 x's are left in the denominator. So here we didn't do 2 minus 5. We actually did 5 minus 2. So whichever one ends up being the bigger one, we do that one minus the smaller one. But then the remaining x's, or a's, or q's, or whatever they are, end up being in that spot. So another way we could have done this is instead of doing a minus b and putting it in the top, we could have done x to the b minus a and putting it in the denominator. So depending on whether a or b are bigger, depends on whether we do a minus b and put it in the top, or b minus a and put it in the bottom. Okay, well, let's see what else we got. So what did we do here? Well, we had x to the second to the third. Now notice that's different than this one up here. Here this was x to the fourth times x to the fifth. This is x to the second to the third. And we ended up with 3 sets of 2x's each, which gives us 1, 2, 3, 4, 5, 6 x's. So if the problem looks like this, how can we go from x to the second to the third to x to the sixth? Well, hopefully you can see that if we have x to the a to the b, well, that is going to end up being x to the a times b. Okay, these are 3 of our super important rules that we're going to use throughout the unit. There's another one that we'll play with today. So what if we have x to the fourth times x to the third all to the second? So it's kind of a combination of these two. Well, what did we end up with? We ended up with 1, 2, 3, 4, 5, 6, 7, 8 x's and 1, 2, 3, 4, 5, 6 y's. Well, if we go back up here, it actually works just like this one. We multiply exponents when it's an exponent that's then to an exponent again. This x to the fourth is to the second, and we get this x to the eighth. And the y to the third is also to the second, so that's why we get y to the sixth. So if we make up another one, x to the a, y to the b, all to the, let's say, c, well, that equals x to the, we multiply here, a times c, y to the b times c. Now, take a breath. We're going to throw a lot at you for this first day. There's going to be a lot of little rules. And then tomorrow we're going to practice it, and Wednesday, and day 3, we're going to practice it. So just get all these down. We're going to practice 1-step problems today, same as tomorrow. And then the third day, we're going to start putting stuff together. All right, so far we're at 4 different properties. If we're multiplying the bases, we add the exponents. If we're dividing the bases, we subtract the exponents, and whichever one's bigger goes first, and then the expression goes in that location. If we have power to a power, we end up multiplying the exponents. And if we have a product to a power, then we distribute that. It's kind of like distributing. We distribute that c, the exponent outside, into both of these, and they end up being multiplied. Well, let's look at another problem, or another type. So let's type these into our calculator. So if I type into my calculator here, 1 divided by 2 to the, this is the to the button. Oop, I pressed it twice, so it's to the, let's delete that one. Negative, and make sure you're using the negative and not the minus, -3. Well, what happened here? This used to be in the denominator. 2 to the third is 8. So let's see here. This ended up being 8. Okay, well, that's interesting. Let's try this one. 1 divided by, let's bring the calculator down, 1 divided by 3 to the -2. Well, that ended up being 9. So it used to be here, and then it moved up there. So let's try this one. 4 to the -2. Now that's a decimal, but if I hit math and then turn it into a fraction by pressing enter, enter, I get 1 over 16. Okay. Well, let's type this one in. 3 to the second times 5 to the negative second. Again, a decimal, but then that's hard to make deductions from. So if I press math, enter, enter, I end up with 9 over 25. So let's kind of look at what ended up happening here. 2 to the negative third should be, well, 2 to the third is 8. What does that negative look like it did? Well, it moved it out of the denominator. Same thing here. The negative here, 3 to the second is 9. 3 to the negative second seemed to move it up. Here, 4 to the second would be 16, except now it's in the denominator. That moved it down. The 3 to the second has a positive exponent. That stayed put, but the 5 to the negative second moved down. So a negative exponent means that the base is going to move locations. If it's in the numerator, it moves down, and if it's in the denominator, it moves up. So let's look here. So our summary. If we have x to the negative a, that equals 1 over x to the a. Also, if we have 1 over x to the negative a, then that becomes x to the a. So wherever the base is, if it's to a negative exponent, we eliminate the negative by moving it down or up, depending on where it is. All right, so there's, what are we on? We got 1, 2, 3, 4, 5. This is kind of a pair. 5 little rules. And what about these? Well, 3 to the 0. Let's try it on our calculator. 3 to the 0 is 1. How about 4 to the 0? Well, that's also 1. 5 to the 0, 100 to the 0. All of them end up being 1. So this new property is anything to the 0 equals 1. And then just to be complete, as long as x doesn't equal 0 itself. 0 to the 0 is actually called indeterminate, which is kind of like undefined. So that's the end of all the new properties for today. Now let's play with these two a little bit together. What if I made a table of, let's see, let's start with 3 to the 4th. Well, 3 to the 4th, clear it out here, 3 to the 4th is 81. 3 to the 3rd, well, that would be 27. 3 to the 2nd is 9. 3 to the 1st is 3. So how are we getting from 81 to 27, from 27 to 9, and from 9 to 3? Well, I am dividing by 3, and then dividing by 3, and then dividing by 3. And the exponents, I went 4, 3, 2, 1. Well, what would the next one be? 3 to the 0. Well, if I continue this pattern, if I divide by 3, divide by 3, divide by 3, divide by 3, if I divide by 3 again, I get 1. That's why 3 to the 0, or anything to the 0, is 1. Now let's push it one step further. What would be 3 to the negative 1? Well, if we extend that pattern again, we divide by 3. Well, what's 1 divided by 3? 1 divided by 3 is 1/3. How about 3 to the negative 2nd? Well, let's go to our calculator. What's 1 divided by 3? That's 0.3 repeating. If I do math, enter, enter to turn it into a fraction, I get 1/3. If I divide that by 3, I get 1/9. If I divide that by 3, I get 1/27. So this would be 1/9. 3 to the negative 3 would be 1 over 27. Again, we just continue that pattern on. So these two properties are really related because all we have to do is extend the pattern out of the positives through 0 down into the negatives, and we end up with all these fractions. All right, so let's practice. So let's say we were going to work on these. So we have x to the fourth, y to the third, x to the fifth, y. And all we're doing is multiplying there. So let's bring that into the light a little bit better. So if we're multiplying, here I've got 4 x's. It's x times x times x times x. And here I've got 5 x's. X times x times x times x times x. How many x's do we have there? Well, we've got 4 of them and 5 of them. We have x to the 9th. How many y's do we have? Well, this would be y times y times y times y. Now, this often trips students up. There is a hidden 1 on that y that we don't have to write, but writing it makes it a little more obvious why it becomes y to the 4th. Okay, the next one. Well, we don't have the same base, so we can't really combine them, but we do have a negative exponent there. And if we remember, a negative exponent means that it is equivalent to with the positive exponent in a different location. So this is going to move up. The x to the third stays put in the top, and then y to the fifth moves up with it. And then we have nothing in the denominator except for 1, so we don't have to write it. So here, x to the third over x to the seventh. If we remember this property, x to the a over x to the b, if the b is bigger, we want to do b minus a, except it stays in the denominator. So I always think about these as leftovers. If I wrote out all of them and started canceling, I would have 4 x's left in the denominator. Now we always have to put something in the numerator. If everything cancels away, we put a 1. Now, I realize I'm going through this kind of quickly, but I want to make sure this video isn't 40 minutes. If you need to pause or rewind or watch again, please do so. That's the nice part about these videos, is you can pace them yourself. All right, so this one kind of has 2 different things we can play with. Here, we've got x's. We've got 5 x's on top and 3 x's on the bottom. If I started canceling, I'd be left with 2 x's on the top. And for the y's, I'd have 10 on the bottom and 7 on top. Cancel, 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 cancel. And we'd end up with 3 y's left on the bottom. That would be the answer to that one. For the next one, this one goes back to this property, where if we have a multiplication to a power, we can bring that power in and multiply it by each of the exponents that are there. Now the difference here is we've got 3 bases. We've got 2. Now again, there's a hidden 1 here. Writing that 1 is really a good idea. So 2 to the 1 to the third is 2 to the third. X to the fourth to the third is x to the 12th, because we multiply the exponents. And then y to the 5th to the third is y to the 15th. And then this is just a number. 2 to the third is 8. So there is the one kind of 2-step question that we're doing today. Let's look over here. So let's see here. We've got 3 over 6. Now numbers, when they're not exponents, work just like they have since first grade. If you had 3 divided by 6, that's 1/2, so that's going to put a 2 in the denominator. You could write a 1 here, but I'm going to wait on that to see if I need to. So we've got 4 x's on top and 1 on the bottom. If I subtract the exponents, I'd end up with x to the third. Again, there's that hidden 1 there. Y to the 5th over y to the 7th. I've got more y's in the bottom. I've got 2 more y's in the bottom. So that's going to leave me with 2 y's in the denominator. Since I have an x to the third on top, I don't have to put the 1 out front. I technically could, I just don't need to. And the last one for today. So we're multiplying. Numbers, again, work just like they have forever. 2 times 3 is 6. X to the second times x to the fourth. Now remember, when we're multiplying, we add the exponents. If we have exponents, we're adding the exponents. So this would be x to the second times x to the fourth, which means we add exponents and get x to the sixth. We didn't add the 2 and the 3 because they're not exponents. And for the next one, we have x to the sixth times y to the sixth. That would end up being y to the 12th. All right, so that is the end of the lesson for today. If we just do a brief summary, we learned a bunch of properties here. We learned that if we have a negative exponent, I guess it doesn't have a personality, but that is equivalent to if it moves up, or if it's in the top, it moves down. And then anything to the 0 power, except 0 itself, equals 1. I hope that went well for you. If not, contact your teacher, and we'll see everybody tomorrow.